Hello everyone, welcome to my channel Infobot. Today, I'll talk about the anatomy of particle physics. Before start explaining the structure of particle physics, we need to know what particle physics really is. Particle physics or high-energy physics is a branch of physics that studies the smallest building blocks of matter and the forces that govern their interactions. It is a fundamental field of study that provides us with a deeper understanding of the nature of the universe and how it works. One of the main goals of particle physics is to understand the nature of particles and their interactions. I'll only talk about the matter, not their counterparts antimatter. Particles are classified into two categories, bosons and fermions. One of the most significant achievements in particle physics has been the development of the Standard Model of Particle Physics, which describes the interactions of all known elementary particles and their interactions with the fundamental forces of nature. The Standard Model consists of three basic building blocks, 12 types of fermions, 5 types of bosons, and the Higgs boson. First, let's start with fermions. Fermions have a property known as spin, which is similar to the intrinsic angular momentum of a particle. Spin is a quantum mechanical property and plays an important role in the behavior of particles. The fermions are divided into two categories, quarks and leptons. They both have a spin of 1/2, which makes them fermions, and are subject to the Pauli exclusion principle, which states that no two fermions can occupy the same quantum state at the same time. The fermions are divided into two categories, quarks and leptons. Quarks. They are the basic components of protons and neutrons, which make up the nucleus of an atom. Quarks have been the subject of extensive study and have been the key to unlocking many mysteries of particle physics. Quarks were first proposed by Murray Gell-Mann in 1964, who was awarded the Nobel Prize in Physics in 1969 for his work. Gell-Mann suggested that protons and neutrons were not elementary particles but were instead composed of smaller, more basic particles called quarks. This theory was later confirmed by experiments at particle accelerators, such as the Large Hadron Collider, LHC, at CERN. Quarks come in 6 different flavors: up, down, charm, strange, top, and bottom. The most common quarks are up and down quarks, which make up protons and neutrons. Up quarks have a charge of plus 2/3, while down quarks have a charge of minus 1/3. These charges, along with the strong force, hold the quarks together in the nucleus of an atom. Leptons are one of the two basic types of fermions in particle physics, along with quarks. They are fundamental particles that do not interact with the strong force, which is responsible for holding the nucleus of an atom together. There are 6 known types of leptons: electrons, muons, taus, and their associated neutrinos, electron neutrino, muon neutrino, and tau neutrino. Electrons are well-known particles that are responsible for electrical conductivity and chemical reactions in the matter. They are negatively charged and have a mass that is much smaller than that of other particles, such as protons and neutrons. Electrons are considered to be elementary particles, meaning they are not made up of smaller components. There are 3 generations of electrons: electron, muon electron, and tau electron. Electrons in different generations also have different lifetimes, with electrons in the first generation being the most stable and those in the third generation is the least stable. This is because the more massive the particle, the more prone it is to decay into lighter particles. Neutrinos, on the other hand, are much lighter particles that are nearly massless and interact very weakly with matter. They were first proposed in the 1930s to explain certain puzzling observations in nuclear physics, and have since been the subject of extensive study. Neutrinos come in 3 flavors: electron neutrino, muon neutrino, and tau neutrino, and can change from one flavor to another as they travel through space, a phenomenon known as neutrino oscillation. Neutrinos are interesting particles because they are very light and have almost no mass. They are also very weakly interacting and can pass through matter almost undetected. In recent years, the study of neutrinos has led to many important discoveries in particle physics, including the discovery of neutrino oscillation, which suggests that neutrinos have mass. Now let's talk about bosons. The bosons are responsible for transmitting the 4 fundamental forces: the electromagnetic force, the weak force, the strong force, and gravity. Bosons are particles that carry forces and have integer spin, while fermions are particles that make up matter and have half-integer spin. This distinction First, we will talk about photons. Photons are the particles that mediate the electromagnetic force, which is one of the four fundamental forces in nature. Photons are massless and have no electric charge, and they travel at the speed of light. They are responsible for transmitting light and other forms of electromagnetic radiation, such as radio waves and X-rays. W and Z bosons. The W and Z bosons are particles that mediate the weak force, which is one of the four fundamental forces in nature. The weak force is responsible for processes such as beta decay and other types of radioactive decay. The W and Z bosons have mass and can be produced in high-energy particle collisions. Gluons. Gluons are particles that mediate the strong force, which is one of the four fundamental forces in nature. The strong force is responsible for holding the nucleus of an atom together and is much stronger than the electromagnetic force. Gluons are massless and have no electric charge, and they are responsible for transmitting the strong force between quarks. Higgs boson. The Higgs boson is a particle that was discovered in 2012 by the Large Hadron Collider, LHC, at CERN. The Higgs boson is responsible for giving other particles mass and plays a crucial role in our understanding of the universe. The Higgs boson is associated with the Higgs field, which is a field of energy that permeates all of space and gives particles mass. These are the bosons that are discovered as of now. Then what about the boson corresponding to gravity? I'll explain in some other video in the future. So, thank you for watching this video. I hope you've learned something new from this video.